Hello everyone, welcome back to my YouTube channel. In this video, I want to continue to solve a question from Past Paper EJU Mathematics 2020, Course 2, question number 2 from Section 2. So basically, this is the fourth question from this whole past paper. By the way, I got this paper from one of my subscribers, so thank you to you who sent this past paper to me. But we do not know this past paper comes from which session. So if one of you knows this past paper comes from which session, you can type it on the comment box below. Before I start, don't forget to give me your like buttons, share this video to your friend, and subscribe my YouTube channel if you like this video. Oh, by the way, the question is a little bit blurry, so I think you should change your resolution into HD so you can see the question more clearly. Okay, let's start to solve this question. This question is talk about complex number. When we express the complex number 8 plus 8 square root of 3i in polar form, we have blah blah blah. So, I have a complex number. The number is 8 plus 8 square root of 3i. Let us assume this complex number with, let's say, a. So I have a equals to 8 plus 8 square root of 3i. If we want to express this complex number in the polar form, we need to find the modulus and argument. This is the modulus of the complex number, and this is the argument of a complex number. To find modulus and argument of a complex number, you can use formula. Modulus of complex number can be found by using formula square root the real part, which is 8 squared, plus the imaginary part, which is 8 square root of 3 squared. This is how we can find the modulus of a complex number. 8 squared is 64, and then 8 squared, 64, times 3, you will obtain 192. If you add them, I will obtain 652. So the modulus of A is square root of 256. Square root of 256 is equals to 16. So 16 is the modulus of the complex number. In the polar form, modulus is right in the front here. So Mn is 1 and 6. And then, to find the argument of a complex number, you can use formula argument of a complex number. I usually write it down as alpha. Argument of a complex number is basically tan inverse the imaginary part over the real part. So argument of A is equals to 8 square root of 3 divided by 8. If you cancel out 8 here, you will obtain alpha, which is argument of A, is equals to tan inverse of square root of 3. Tan inverse square root of 3 is equals to 60 degrees. Argument is usually expressed in radian. So 60 degrees in radian is pi over 3. So the argument of A is pi over 3. Therefore, I obtain O and P here. This is the argument of A. So O is 3, P is also 3. If I write it down, my complex number A in polar form is equals to 16 cos pi over 3 plus I sine pi over 3. This is how we express a complex number in polar form. This is what we call a Cartesian form. Okay, let's move to the next question. Consider the complex number z that satisfies z to the power of 4 is equals to 8 plus 8 square root of 3i. In the range argument z between 0 until 2 pi. This is argument z, yeah? We see that modulus of z equals to blah blah blah. So I need to find the modulus of z. I already know that 8 plus 8 square root of 3 has modulus equals to 16 and argument equals to pi over 3. And then I already expressed a in terms or in the form of polar. I can also express a in the form of exponential. So we have three forms of a complex number. The first one is called a Cartesian form. This is Cartesian. And then the second one is polar. Then the last one is exponential form. If I want to express a in exponential form, a is equals to modulus e to the power of alpha I. R is the modulus and alpha is the argument. So a is equals to 16e to the power of argument, which is pi over 3i. This is a in the form of exponential. So I already know that z to the power of 4 is equals to a. So z to the power of 4 is equals to this one. I will write it down here. Z to the power of 4 is equals to 16e to the power of pi over 3i. So to find the modulus of z, remember the number here is the modulus, and then the index or power here is the argument. So if I want to find the modulus of z, I can simply fourth root this 16. So if I want to find z is equals to the fourth root of 16e pi over 3i. If you calculate fourth root of 16, you will obtain 2. I will leave this part as e to the power of pi over 3 times I. I still do not calculate or simplify this one. So we see that the modulus of z is equals to q modulus is this one. So the modulus of z is equals to 2. So from here, I know that modulus of z is equals to 2. And then there are 4 such complex numbers z. There are 4 complex numbers of z. When these are denoted by z1, z2, z3, and z4, in the ascending order of their argument, we have that argument z1, z2, z3 over z4 is equals to blah blah blah. Once I got the modulus, to find z, I need to know the argument. We know that z to the power of 4 equals to a complex number, then z has 4 solutions. That's why they tells us that there are 4 complex numbers that satisfy this equation. Because we have an equation with degree 4, that means there are 4 different solutions for z. To find those 4 solutions, we need to write down the argument in the general form. So if I write down the argument just only pi over 3, I cannot find the 4 solution of z. So I need to write down the argument in the general form. If I want to write down pi over 3 in general form, I just add 2 pi here. So I will add it with 2 pi. And then I will put a bracket I. This is the general form of the argument. As you can see, I have pi over 3, which is 60 degree. If I add it with 2 pi is 360 degree. I will have the same position of angle. I have 60 degree, and then if I add it with 360 degree, I will have 420. Of course, 420 is the same as 60 degree. So I will change this argument in the general form like this, and I will also change it here. Pi over 3 plus 2 pi I, like this. This is the z in its general form. So if I want to find the argument of z, I can calculate it by using this formula. I think I forgot to put the constant here, yeah? I need to put k here, k 2 pi. Wait a minute, let me rewrite it. We need to put k because we need the general form, like this. So when I want to calculate z, wait a minute, I will write down. I think I will erase this. Oh no, I will erase this one. Okay, and then I will put pi over 3 plus k times 2 pi, and then I will put I at the back. Wait a minute, yeah. I will put I here. Oops, sorry. I will put I here, like this. So when I want to find z, I just do the fourth root of this one. As you can see, z is equals to 2 times fourth root means to the power of 1 over 4. So when I want to calculate e to the power of blah 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 and then fourth root, I can write it down as e to the power of pi over 3 plus k times 2 pi I to the power of 1 over 4. If you simplify it, you will obtain z is equals to 2e to the power of pi over 3 times 1 over 4. You will obtain pi over 12. And then k times 2 pi times 1 over 4, you will obtain k pi over 2. Don't forget to put I at the back. This is the general form of z. Remember, argument is this one. This is the argument of z in the general form. To find all the argument of z, which is argument of z1, z2, z3, and z4, we just substitute k by using a whole number. So let's say argument of z1 is alpha 1. If I substitute k equals to 0, I will obtain pi over 12 plus 0, which is pi over 12. And then the argument of z2, if I assume it as alpha 2, the argument of z2 is pi over 12 plus, you can substitute k by 1. The first one, k is equals to 0, and then the second one, k is equals to 1. Wait a minute, this is not 12 but 2. If you calculate it, you will obtain 7 pi over 12. And then alpha 3 is equals to pi over 12 plus 2 pi over 2. If you calculate this, you will obtain 13 pi over 12. And then the last one, the argument of z4, which is alpha 4, is pi over 12 plus 3 pi, over 2. If you calculate it, you will obtain 19 pi over 12. So this is the argument of z1, z2, z3, and z4 in the ascending order. Once you obtain the argument of z1, z2, z3, and z4, you can calculate argument of z1 times z2 times z3 over z4 by using the properties of argument. Of course, you need to know the properties of argument. If you want to calculate argument z times w by using properties of argument, argument of z times w is equals to argument z plus argument of w. And then if you want to calculate argument z over w by using the properties of argument, argument z over w is equals to argument z minus argument w. This is very similar with the properties of logarithm. Okay, so if you want to calculate the argument z1 times z2 times z3 over z4 by using the properties of argument, argument of z1 times z2 times z3 over z4 is equals to argument of z1 plus argument of z2 plus argument of z3 minus argument of z4. So my answer is alpha 1 plus alpha 2 plus alpha 3 minus alpha 4. Since I already know alpha 1 is pi over 12 and so on, I can substitute this value to my equation. So my final answer is pi over 12 plus 7 pi over 12 plus 13 pi over 12 minus 19 pi over 12. If you calculate this, you will obtain 21 pi over 12 minus 19 pi over 12. So your final answer is 2 pi over 12, which is pi over 6. So my final answer for letter R here is 6. Okay, let's continue, yeah? Question number 3. Consider the complex number w satisfy w to the power of 8 minus 16w to the power of 4 plus 256 is equals to 0 in the range from 0 until 2 pi for argument of w. There are 8 such complex numbers w. Why there are 8 such complex number of w? Because w is the equation with degree 8. In complex number, the degree of the equation represents the number of solution of that equation. Since the equation has degree of 8, that means there are 8 different solutions. Let us denote them by w1 until w8. So we denote the solution of w by using w1 until w8 in ascending order of their argument. Then 4 of these coincide with numbers z1, z2, z3, and z4 in 2. That means 4 of these 8 solution is the same as z1, z2, z3, and z4. That is blah blah blah. So we want to find which w is the same as our z. To find or to solve this question, I will assume w to the power of 4 as a variable. Let's say I will assume w to the power of 4 as, let's say, b. So I have w to the power of 8 minus 16w to the power of 4 plus 256 is equals to 0. This is the equation. To solve this equation, I will assume let b is equals to w to the power of 4. That means now my equation can be written as b squared minus 16b plus 256 is equals to 0. I can solve this quadratic equation by using quadratic formula. Of course, you cannot factorize this equation, yeah? So, instead of factorization, I will use quadratic formula. If I solve it by using quadratic formula, I will obtain b equals to minus negative 16, that means 16, plus minus square root of negative 16 squared, which is 256, minus 4 times a times c over 2. If you simplify the expression inside the square root here, then you will obtain 16 plus minus square root. I can factorize 256. Then I will obtain 256, 1 minus 4 over 2. You can take the 256 outside because square root of 256 is equals to 16. Then b is equals to 16 plus minus 16 square root of negative 3 over 2. I can divide all the terms by 2. That means I have 8 here and here. And then square root of negative 3 in complex number can be written as 3i. You need to remember the concept of complex number, yeah? In complex number, square root of negative 1 is equals to I. So if I have square root of negative 3, I can write it down as square root of 3 times negative 1. I can write it down square root of 3 times square root of negative 1. That means I have square root of 3i. So the solution for b is equals to 8 plus minus 8 square root of 3i. We have two solutions because I have a equation with degree 2. So I have two solutions here. But the question do not want us to find b. They do not ask us to find b. They ask to find w. So I need to substitute it back into w. Since I have two value of b here, that means I have two value of w to the power of 4. The first one is w to the power of 4 is equals to 8 plus 8 square root of 3i. And then the second one is w to the power of 4 is equals to 8 minus 8 square root of 3i. From this equation, we will obtain 4 value of w, which is the same as z. Because if you remember, the previous question, we have z to the power of 4 is equals to 8 plus 8 square root of 3i. The same thing as this one. But I do not know w in this part has w, I do not know which notation here. So I will write it down like this. W is equals to, I do not know, yeah. This one is w what? So I have W, the first one is, remember the modulus is 2. The modulus is 2. The argument is this one. So we have four solutions. If I write it down in the exponential form, I have 2e to the power of, the first one is pi over 12i. And then the second one, we do not know which w here. 2e to the power of 7 pi over 12i. And then the third one is 2e to the power of 13 pi over 12i. And then the last one is 2e to the power of 19 pi over 12i. This is the first 4 solution for W. This is the solution that is coincide or the same with Z1, Z2, Z3, and Z4. But we need to solve this one first so that I can arrange the W1 until 8 in the ascending order of their arguments. So I need to solve this one first. If you want to solve this one, you can use the same method as this one. The one that is different is only the argument of 8 minus 8 square root of 3i. So if you assume this complex number as C, I will assume that complex number as C. C is equals to 8 minus 8 square root of 3i. We can find the modulus of C by using the same method here. I can find the modulus of C and the argument of C. If I calculate the modulus of C, I do not write it down, or I do not write down the working, because the working is very similar with the previous question. So you can use this part to practicing the complex number. The modulus is the same, which is 16, and then the argument of C, or I will write it down by theta, is equals to tan inverse the imaginary part over the real part. So negative 8 square root of 3 divided by 8. Divide by 8. As you can see here, the argument is tan inverse negative 3. Tan inverse negative 3 is equals to negative pi over 6. I use the one at the fourth quadrant. Why? Because if you see this complex number, the real part is at positive axis, but the imaginary part is lies on the negative axis. So if you draw this complex number in the Argand diagram, the position of 8 minus 8 square root of 3i is somewhere here. So the location of C is in the fourth quadrant. So I should write down the argument in the fourth quadrant. You cannot write down this argument in the second quadrant. Even though in the second quadrant tan inverse negative 3 or tan is also negative. But since the position or location of C is on the fourth quadrant, so the argument must be write down in the fourth quadrant as well. Okay, once you get the argument of C, you can write down W to the power of 4 is equals to same like this one. You have 16e to the power of negative pi over 3 plus k times 2 pi I. 16e negative pi over 6 plus k times 2 pi I. And then since we want to find W, we can take the fourth root on the right hand side. So W is equals to, the fourth root of 16 is equals to 2. The fourth root of this, if you simplify it, you will obtain, sorry, this is not pi over 6, yeah, this is basically pi over 3, my bad. I already made a careless mistake here. This is not pi over 6 but pi over 3. Wait a second, let me redo it. Pi over 3 here. Tan inverse negative square root of 3, yeah? It is negative 60 degree. So 3 here, and then if you fourth root it, that means you power it to the power of 1 over 4, then you will obtain e negative pi over 12 plus k pi over 2i. And then if you substitute k by using a number, you can substitute it by using 0. But if you substitute it with 0, the argument is negative pi over 12, which is outside the range. So if I write it down, yeah, the first one is when k equals to 0, you will obtain W is equals to 2e negative pi over 12i, but we should reject this one, because the argument is outside the range of argument of W. So you cannot use k equals to 0, but it's okay. Just keep going. You can substitute k by 1, then you will obtain W is equals to 2e negative pi over 12 plus pi 1 over 2 pi. Then you will obtain 5 pi over 12. And then if k is equals to 2, W is equals to 2e. You substitute k by 2, you will obtain negative pi over 12 plus pi. If you simplify it, you will obtain 11 pi over 12. And then k equals to 3. W is equals to 2e to the power of 17 pi over 12i. And then k equals to 4, you will obtain 2e 23 pi over 12i. If you substitute k equals to 5, the argument will outside the range, so we cannot take k equals to 5. So basically at the end, if you do it correctly, you will obtain 8 different solutions. There must be 8 different solutions. You cannot obtain more than 8 or less than 8 if you do it correctly. By observing the argument here, you know that which one is the W1 and which one is W2 and so on. So if I write it down in ascending order of their argument, the smallest one is this one. So this is W1, and then the next one is this one, W2, and so on. This is W3, and then this is 4, this is 5, this is 6, this is 7, and this is 8. That means I already know the solution of W, which is coincide or the same with Z, is W1, 3, 5, and 7. So the answer for letter S, T, U, and V is already obtained. And then the final question is, also we have that W1 times W8 is equals to blah blah blah. Since we already know W1 and W8, so I think it is easy for us to calculate W1 times W8. W1 times W8 is equals to this one times this one. You will obtain 2e power pi over 12i times 2e to the power of 23 pi over 12i. If you simplify it, you will obtain 4e to the power of, don't forget, if we have an exponential with the same base number and then we times them, the index or the power should be added up. So pi over 12i plus 23 pi over 12i is equals to 2 pi. This is the modulus and this is the argument. I forgot to put I. Once you got the modulus and argument, you can change or express this complex number into the polar form. For cos 2 pi plus I sine 2 pi. You already know that sine 2 pi is equals to 0. So we can cancel out this one. And then you also know that cos 2 pi is equals to 1. So W1 times W8 is equals to negative, no, I mean 4. 4 times 1, yeah? So W here is 4. And then by using the same method, you can calculate W3 times W4. This is W3 and this is W4. So if I want to calculate W3 times W4, I will do it directly. 2 times 2, you have 4. E to the power 7 pi over 12 plus 11 pi over 12. That means you will obtain 18 pi over 12. And then if we convert it into polar form, I think I can simplify the argument here, yeah? 18 over 12 is the same as 3 over 2. Like this. And then if you express this in polar form, you will obtain 4 cos 3 pi over 2 plus I sine 3 pi over 2. Cos 3 pi over 2 is equals to 0. But sine 3 pi over 2 is equals to negative 1. So you can cancel out this one. Sine 3 pi over 2 is negative 1. So your final answer is 4 times I times negative 1. Then your final answer is negative 4i. So the answer for letter XY here is negative and 4. Okay, this is the end of this video. I hope you can enjoy this video and you can understand my explanation. And I hope I can see you guys on my next video. Thank you and bye-bye.